Okay, welcome to Module 7, which is network analysis. So in this course, this is probably one of the harder tools that you're going to be using in ArcGIS. So it's okay that you're going to get frustrated, just so you know, but it is something that that is a little bit more advanced. It's more of an advanced tool, but it is a very helpful tool. So we're going to start off with this objective, which is defining the networks. And then the last, after this, I'll only do really short lectures of, I think, Objective 3 and Objective 4. And then that will be it. Objective 2, there's not much there in the PowerPoint to go through, but you need to go there and work on the exercise instead. So, but this one is the introduction to the entire module. So in this one, we're going to define networks. We're going to explore the different types of networks that are available and why we use them. So what is a network? Well, networks is a connection of data that comes together and they are linked together in some form. In GIS, there are specific network components that you need in order to create a network. And so the first thing that we need is we need a route that has a series of lines and points, which are, like as it says, a series of edges and junctions. So we need that to start with. We also need how these elements connect, and so therefore it uses topology. So what's key with this, though, is it dictates the direction of flow. So it does actually provide a direction in topology. So when I say dictate flow, it dictates the direction of flow. So people, resources are goods. It's also dictating the efficiency of the flow. So, how fast or how many or how short, that kind of thing. So for example, here's a quickest route. So how can I get from point A to point B in the fastest way possible? So it does the calculation and figures it out from all of the different roads all the way around, and it figures out where you get there. We're probably used to seeing that with like Google Maps, if you ever use that, or OpenStreet. It kind of all do that type of network for us. There's also the closest facility. So again, it does a calculation. It says, oh, I'm located here. Which one of these facilities is closest. We might have some fun with that when we're dealing with like, where is my closest Tim Hortons, right? So it'll calculate where it is and it'll figure out what the closest location is for you. Then there's also service area. So this is really good for looking at, for example, hospitals or like if you work for cellular service providers, what the service area for the cellular services, and then you can figure out what that service area looks like and where it's poorer or better, and then you can also see areas which have gaps. So when we're also looking, we can also look at routing. So what is one direction to another? Can I go from, point 1, where is that? It's probably up in here. So point 1, can I get up to 10? What's another route to go from point 2 here up to 10 up here? Can I go from this one to this one? So it will actually send you down individual roads to give you the best option and multiple options. And the other one is location allocation. So this is, again, you're trying to find out, how many points around here, let's say, if these little triangles are there. I have this one and this one. And let's say, for example, I want it within a certain traveling distance or a certain travel time. Then I will figure out which one of these points is going to fall within that. And then if it falls outside of that, it doesn't get included. So if we look at transportation, because that one's like the obvious one, right? We use transportation all the time, so therefore we want to figure this one out, the best way to connect it. So data typically flows or travels on lines, which is known as edges in networks, in both directions. So there are some one-way streets. For example, downtown Calgary, there's one-way streets. So we need to be aware of that when we are designing our road networks, just so that it's clear when there is not direction in both both directions. Um, anyway, so you can include different modes of travel as well. So railroads, roads, and waterways, or bike, or transit. So there's a whole array of different things that you can put together with a transportation network. So some of the things that we might want to answer, for example, is what's the best path to travel to 16 delivery locations? So if you're working for like one of those delivery companies, totally gone. I know there's a bunch of them, but I can't remember at the moment. I don't use them, so you got to do a delivery, and you've got to pick up food, and you got to do all these like really, really fast. So what's the best path? And it'll do that calculation. What is the likely service area of a fire station based on travel time? So again, how far away are you? The shortest path from point A to point B, and also which is the shortest path that avoids narrow streets or slow streets or, right? So this is just a couple examples of what we could be looking at for a transportation network. Then we also have utility networks, and so this one is looking at data that typically flows in one direction at a time. So again, like a really good example is one-way streets, or we're looking at telecom. It goes from the cell tower out. So it'd be utility. That's more specific to like actual utilities, but that's not what utility network means. It looks at material flow dictated by network geometry and sources, or sinks as it's called. So you can see how people move in one direction, or you can see like water flow, right? That's another one, and that's all dictated by this geometry. So a good example of these utility networks would be, I have a valve fail in like my main water system. Who's going to be affected? If you have to close a pipe for repairs, can you reroute the water to minimize service disruption? There's contamination. So, how will it propagate through the network if I have contamination at one site? And which sewer lines serve only residential customers, right? So we can take a look at all of those. Then we're looking at a network structure here, in this slide. So what do we need? We need a path and a description. That's what it comes down to. So the network path dictates the path of the travel, and it has feature classes in it. The description is the tables that describe the network relationship. So they all come together in this like logic table that says, hey, this is how it all works together. So some things that we need to consider are like, for example, other examples of networks. So I gave a few. So think about what would be some other things that might follow lines and need points and would be interconnected. So it's something you can think of there. Then some of the problems associated with networks. What would be some of those problems? For example, what if you have an accident, or like car accident, and you don't have that, like you don't have live time information, right? So that's some of it. Some of it might be that it's taking back alleys rather than actual streets. Sometimes it's a misinterpretation of the person creating the data. There's always problems that can be associated with it. And then, for you guys, can you build a full network with ArcGIS Basic? Take a look into that and see if you can do that. So one of your activity this time is to define each of these. So go through and define them. If you want to post them on D2L, feel free to after you've done so. And then you can compare your definitions and descriptions. And then but you don't have to, but you certainly can, and we can take a look at that. So in summary, there are two types of networks that exist in ArcGIS. There's utility and there's network. and network is specific to transportation. The ArcGIS Standard and ArcGIS Advanced are required to edit and construct a network. And then ArcGIS Basic can only read networks, so unless you purchase a network analyst license. So if you have a standard license, you will be okay and you can do it. So there's a tutorial on ArcGIS, ArcGIS's website, Esri's website, and you can go check that out there. And that is everything for this topic.